Welcome to the Module 11 Part 2 video notes. In this section we're going to look at the binomial distribution. So this is a very specific application of a probability distribution, a discrete probability distribution to be exact. There are 4 requirements that must be satisfied for an experiment or for a probability distribution to be a binomial. Those requirements are independent trials. So that means knowing the outcome of one trial does not give you any information about what's going to happen with the next trial. The second requirement is you need to have a fixed number of trials. So what that means is you have to start the experiment saying, okay, I'm going to look at 20 people and determine if they have cancer or not. What you cannot do is you cannot say, okay, I'm going to talk to however many people it takes for me to find 20 people with cancer. That's a different type of experiment and not what we're going to be covering. So you have to go into the experiment with the idea of how many times you're going to talk to somebody or how many times you're going to flip the coin. Okay? The third requirement is that there are only 2 possible outcomes. And we call these outcomes a success and a failure. The success and failure is just simply differentiating between the outcome that we as the experimenter are interested in versus what we're not interested in. So if we're doing an experiment and we want to determine whether a person has cancer or not, because we are interested in the person having cancer, that is considered a success. Even though logically having cancer is not a success. But since we as the researcher are interested in that, that's what we're going to classify as a success, is finding somebody who has cancer. All right, and then the last requirement is that the probability of success must be the same for all trials. So we can't do anything where we're sampling without replacement. So like if we're drawing from a deck of cards and we're interested in drawing an ace, so we would look at the card and we would say it's an ace or it's not an ace. What I have to do after each draw is I have to replace the card that I drew and reshuffle it so that I don't change the probability of drawing an ace. If I pull a card and I look at it and I mark whether it was an ace or not an ace and then I set it aside, well, now I only have 51 cards in my deck instead of 52, so I've changed the probability of success. I've changed the probability that I get an ace on the next card. So we have to make sure we have consistent probability of success. In most things talking about people have the same probabilities of success from one person to another. Okay? So some notation that you're going to need to know for this section, a lowercase p stands for the probability of success. So if we're drawing an ace from a deck of cards, the probability of success would be 4 out of 52, and then you would convert that into a decimal. N is the number of trials, so the number of times you're going to draw a card from a deck of cards. And X is equal to the number of successes. So when you drew the card from a deck of cards, how many times did you get an ace? Okay. Now the mean and the standard deviation of a binomial. These formulas are a little bit different than what we saw in the previous section. Even though this is still a discrete probability distribution, we can actually simplify these equations. with the binomial. So the mean of a binomial is equal to the number of trials times the probability of success. That's it. Nice and simple, right? Nothing too crazy. And the standard deviation is equal to the square root of the number of trials times the probability of success times 1 minus the probability of success, or the complement of the probability of success. And that's it. Those formulas are much simpler than what we saw in the previous section. Okay. So let's go ahead and get into an example. Oh, well, we're going to do the mean and standard deviation first. Still looking at an example though. So the RTD runs 15 trains through the Auraria campus stop from 8 a.m. to 9 a.m. daily. Each train has a 35% chance of arriving late. Trains are all independent of each other. So if the W line train is late, that doesn't change the probability of the C line train being late or the E line train being late. Okay? They're all independent of one another. So we have independent trials, okay, because we were told they're independent of each other. We have a constant probability of success. Each train has a 35% chance of arriving late. We have a fixed number of trials. We're going to be looking at 15 trains. And we only have two possible outcomes. Either the train is late or the train is not late. If the train is on time, it's not late. If the train is early, it's not late. So there are only two outcomes. It's either late or it's not late. So we're going to find the mean of this distribution. So the mean is going to be equal to the number of trials, which is 15, times the probability of success, which in our case, a success is that the train was late. Again, doesn't really make sense for that to be a success, but that's what we as the researchers are interested in. So 5.25 is the mean. So on average, 5.25 trains are late that come through the Auraria West Station. And then the standard deviation is going to be the square root of 15 times 0.35 times 1 minus 0.35. And again, you can type this into your calculator exactly like this. And we get 1.8473. And again, standard deviation is still a measure of spread. It's still letting us know the average distance for a data value from the mean. Okay? So that is the mean and the standard deviation. So let's go ahead and look at how to calculate some probability with this. So we're looking at the same example. So the first question I've asked is, what is the probability of exactly 4 trains arriving late? So there are two ways that I'm going to show you on how you can find the answers to these probability questions. One is using a website that I'm going to use during the notes called GeoGebra. GeoGebra is great because it allows you to see the graph that is being used to calculate these probabilities. It's very visual. Then I'm going to post a subsequent calculator tutorial video on how to calculate all of these probabilities in your calculator. The exam is going to require you to use your calculator. You are not going to be allowed to use the GeoGebra website when you go to take your exam. While you're doing homeworks and your discussion posts next week, I highly recommend you use both. Okay, maybe try it in your calculator first and then go to this GeoGebra website that I'm about to show you to check your work. Okay, so let me go ahead and go to GeoGebra. I will post a link to this with this week's materials as well. So what I did is I'm on the GeoGebra probability section, and right here is a list of all of the different probability distributions that there are. Okay, right now we are focused on a binomial. So I clicked on the binomial, And I went ahead and set this up a little bit already. So I said that n, which is the number of trials, was equal to 15, and our p, which was probability of success, is equal to 0.35. Now notice in the upper left-hand corner we have a mean of 5.25 and a standard deviation of 1.8473. So there we've checked to make sure that we did those correctly. Okay, so now what we have here is we have a histogram that is showing us the probability for an individual value, starting at 0 and going all the way up to 15. So on the histogram over here, you can see that the height of the bar for 0 is very small. And if you look over on the right-hand side, there's a table where you have k, and then the probability of x equals k. So k is the number of successes in this on this website. So in the notes, it's x. On GeoGebra, it's k. It's a little x. So the probability that 0 trains, exactly 0 trains, arrive late is 0.0016. If we jump down, the probability that exactly 1 train is late is 0.0126. And we can see on the histogram that the bar for 1 is a little bit higher now. Okay, so the height of each bar represents the height of the probability for that particular outcome. So the first question that we had in the notes, let me go back to those, says, what is the probability of exactly 4 trains arriving late? So I want to know the probability that x equals 4. So I'm going to go back to GeoGebra. Oops. There we go. Back to GeoGebra, and I'm going to look at x equals 4, which is, k equals 4, which is 0.1792. So the probability that exactly 4 trains are late is 0.1792. So there's a 17.92% probability, or percent chance, that exactly 4 trains arrive late to the station. Okay. So now the next example, or the next problem says, what is the chance of exactly 3 trains arriving on time? And that's a key word. So we've been given the probability that the train is late. I want to know the probability that the train is on time. So there are 2 ways you can solve this. You can either change the probability of success from 0.35 to 0.65, which would be the probability that the train is not late. Or what I think is easier is if there are 3 on-time trains, then that means there are 12 late trains. So the probability that 12 trains are late, looking at GeoGebra, come down here, 12 is 0.0004. So a very small probability that only 3 trains are on time. All right, and now in here, what is the chance, or what is the probability that at least 10 trains will arrive late? So we want to know the probability that x is bigger than or equal to 10. At least means greater than or equal to. And think of it this way, if you have to be at least 16 to have a driver's license, you cannot have a driver's license when you're 15. You can have one when you're 16, you can have one when you're 17, 18, 19, all the way up to 100, or infinity, really. Okay, but you cannot have one when you're under 16. So the key word here, at least, means we're looking for the probability that x is greater than or equal to 10. So this is the great thing about GeoGebra, is I can go into GeoGebra, and if you look at the bottom, we have the probability that x is less than 11 right now. If I click on this third button in that row, it's going to flip it to the probability that x is greater than or equal to some number. And the number I'm interested in is 10. So I'm going to change this 11 to a 10. And I'm going to hit the little enter button. So now what it did is it looked at 10, 11, 12, 13, 14, 15, all of those individual probabilities, not 9. I don't want 9. I want 10 through 15. So it took the probability that 10 trains are late, plus the probability of 11, plus 12, plus 13, plus 14, plus 15. Because at least 10 means 10 or more. And as we learned back in Module 8, the keyword or means we're going to add. So saying I want the probability that at least 10 trains are late means I need to take the probability of 10 or 11 or 12 or 13 or 14 or 15. So I need to add all of those probabilities together. And when we do that, we get 0.0124. So I'm going to go ahead and fill this in. 0.0124. Okay. Now, what is the chance that at most 3 trains will arrive late? So now this is the opposite side. If your parents tell you that you're allowed to have at most 3 friends over, back when you were a kid, you know, and your parents would be like, oh, we don't want the house full of 1,000 crazy kids running all over the place. You can have at most 3 friends come over for your birthday party. That means you're not allowed to have 4 friends. You could have 3 or 2 or 1 or even 0 friends come over. So at most means we're looking for the probability that x is less than or equal to 3. So going back to GeoGebra, now I want to click back on this left-hand side so that it flips it. So now what it's showing me is the probability that x is less than or equal to 10. But I don't want 10, I want 3. And it's not cooperating. There we go. And I hit enter. So now it took the probability of 0, 1, 2, and 3, and it added those together because 3 or less, again, we have that keyword or, which means addition, and we get 0.1727. Woo! I don't know what just happened. I didn't think I wrote that in the wrong spot, but maybe I did. Go back real quick. All right, probability that x is less than or equal to 3 equals 0.1727. So about a 17% chance that 3 or less trains will be late. And then the last example for a type of question we could see with this is what is the chance that between 2 and 4 trains arrive late? So the probability that 2 to 4 trains are late. Whenever we say between 2 and 4 or between 5 and 9 or whatever it is, the numbers that are given are included in the probabilities. Okay, so alternatively, I could write this like this, which the only number between 2 and 4 is 3, not including 2 and 4. So this would be the same thing as the probability that x equals 3. But that's not what we want to do. We want to include the 2 and the 4 in the probability. So going back to GeoGebra one more time. Now there's this middle button that we haven't used yet, and that'll give us the between probabilities. So the probability between 2 and 4 is what I want. 2, and change this guy to a 4 if it'll let me. There we go. And hit the enter button. And now we have 0.3378. So it took the probability of 2 plus 3 plus 4 and gave us 0.3378. Oh, I don't know why it keeps doing this. It's overlapping. So I'm just going to come back down. Probability 2 less than x less than 4 is 0.33, I don't remember what it was, 78. I was able to just take a peek at it real quick. Okay. Now another question I might ask you is, what's the probability that more than 10 trains will arrive late? So more than does not include the 10. So that would be the probability that x is greater than or equal to 11. And then if I said less than 3 trains will arrive late, that means we're not going to include 3. So that's the probability that x is less than or equal to 2. And I have a helpful sheet that will help you guys. It'll also help you with the calculator, because the calculator is not quite as nice as GeoGebra when it comes to calculating these probabilities. You're going to end up using the complement rule a lot more with the calculator than we had to with GeoGebra. And I will show you all of that in the calculator video that's to come. Okay, so as a review, we calculated some probability for the binomial. We calculated the mean and the standard deviation of the binomial. And we went through the 4 requirements for an experiment to be a binomial. So that is it for Module 11 Part 2 for these notes. The calculator video will be posted as well.